How you doing? This is Bob Sorensen. I'm one of the analysts here at Hyperion Research. I want to thank everyone for attending or participating in this webinar this afternoon. I'm being U.S.-centric. I'm here in the Eastern U.S. time zone, but so I don't know where everyone else in the world is. If people are here late at night or early in the morning, an extra vote of thanks for showing up and participating or listening in. It was a fascinating session, and we had lots of good chat back and forth during the presentation, but this is the time where we have a chance to really talk to the speakers live and maybe get a little bit of discussion going. The one thing I do remind everyone, if you look at your screen right now, you'll see up on the top right a little sentence there that says take the survey. We'd really like to remind you to pop that open, take the survey, and give us some of your honest and open feedback about things you like, things you didn't like, and issues there going forward. It's really important for us to get a sense of what's going on here for activities like this. So we will appreciate any comments you have. I will mention that we have been collecting the questions and answers that have been published on the chat sessions, and anything that we didn't get to then or that we don't get to now, we will do our level best to try to make sure that those questions are answered to the satisfaction of the people asking those questions. So we do take this particular part of the activity very seriously. So I want to start out with kind of a real holistic question. Keith, I'm going to put you on the spot here right now as kind of our, one of our resident oil and gas experts. What are some of the things that you heard today that got you most excited about some of the technology possibilities of the technology you heard?
So several things. One is that the compiler and the development environment is continuing to mature nicely. Clearly, memory bandwidth is very, very important for the work that we do. And to see that the level of support that Fujitsu and HPE are providing to help broaden this availability is really encouraging. I think those were probably the main things that I heard, Bob.
Great. Did anybody else want to kind of jump in and talk a little bit about something that they heard that surprised them or got them even more intrigued with what's going on with the processor here? Okay, let's go on. And if anybody wants to jump in on that question, go right ahead. I was really interested hearing someone actually threw out the phrase Jupyter notebooks at one point, and one of the things that interests me as a technology person is looking at taking some really interesting leading edge research, the kind of stuff that we heard about today, and how that actually moves from a research environment into a production environment. How you bring in the subject matter experts, say the geophysicists and the geologists, moving this from right now what is primarily a kind of an architectural benchmark activity, a lot of the things we heard here today, to moving that into a production environment where subject matter experts can take advantage of those capabilities. Is there a sense within the community, and I'll point this first to Takayuki, that the technology here has the kind of software development tools to allow the process to move from an R&D environment into a production environment in a relatively painless way?
Pardon me?
I'm interested in finding out what kind of software tools could help end users take advantage of this technology to move it into a more general purpose production environment.
Mm-hmm. So how should I say? So we have some. We have been developing some proprietary systems, but in this FC is a very industry developed standard processor and a compliant architecture. And so we have a lot of compilers from Fujitsu and ARM and HPE, and also GCC and LLVM is available on this processor, and also the standard Linux system is available. So when you can, standard open source software on Red Hat or so they can be available. So I think application migration to HTTP/FS is very easy, I think. So, but I think I have a lot of users. So I'd like to hear the impression for such oil and gas users today.
All right, great, thank you. A question for the gentleman from KAUST. The benchmark work that we heard a lot about today was really focused on the processor level. I'm interested if you had any thoughts on how the use of this particular processor would have an impact on, say, the overall system design for machines that will ultimately be used in. Or is there requirements for any, I don't want to say unique, but at least targeted architectural features at the systems level that this particular component for oil and gas end uses would really either be required or would at a minimum be an important aspect of that? And perhaps the gentleman from HPE could or ARM could comment on that question as well.
We're starting with KAUST, yes?
Yes.
Hatham, you want to add some comments on that?
Sure, I'm happy to try to answer the question. So what we heard about on this GIRI benchmark was about how we could leverage temporal blocking for getting high performance on various architecture, and this presentation of Long focused on the AE64FX. The idea behind this diamond tiling or temporal blocking is to have basically to get performance, you need to have an architecture which has a large capacity in terms of last level cache. It's something that we've seen that it did pay off on various Intel and AMD architecture, and we tried to do the same on A64FX, and we were able to get similar performance to the standard spatial blocking scheme. And on other architecture, we've seen that it actually outperforms spatial, as the traditional spatial blocking scheme. So, what we really would like to see, and it seems that some vendors are already adopting massively this, hardware design and getting a larger capacity for this last level cache. It's something that we'd like also to see on Fujitsu architecture moving forward, so that we could really leverage performance thanks to this dimension of temporal blocking.
Longqiu or Zhuxihang, do you have any additional comments on either the system design implications or what complexities were involved in porting some of the existing software that you had onto the new Fujitsu architecture?
I think the Fujitsu programming environment is a full package. So when we put it to the Fujitsu, when we put it to Fujitsu ACC4FX architecture, it's quite straightforward. The only thing I adapted the code is to bind the core to with the corresponding core ID. In fact, in ACC4FX, the first core is the number of first core is 12, which is not the case for example for the Intel. We start with 0. So this is the only thing that I did to put the code to that architecture. It's quite straightforward from my experience.
Great.
We ported, as I said, most of our entire seismic processing package, which involves dozens of binaries, involves a large Java-based workload manager visualization package. We ported most of that inside 20 minutes. Most of what we did, it rebuilt and it was fine. The only parts which tripped us up were the parts where we've gone after absolute performance and we've gone after vendor-specific hardware directives. So we've written to AVX 512 intrinsics, or we've gone out and used explicitly very particular Intel libraries which aren't available on any other platform. And so those parts tripped us up, but the rest of our software just ran. It was pretty straightforward. Apart from my perspective, the memory is an issue. For us, and I think for most seismic people, probably 256 gigs becoming the minimum memory you put in a system. And so dropping back to 32 gig requires perhaps a little more thought.
Mm-hmm.
So you need to throw a little more of, I think as Gerard puts it, what did he call them? The magicians, or the software people, to slightly redesign the software to be able to survive in a lower memory environment. But look, it was only a decade ago that we only had 4 gig machines. So it's not that long ago that we had way less. So it shouldn't be too hard.
No one ever said they had enough memory. So that's a fair
well, I heard earlier that
John
Brent,
Shelf said they had too much.
Yeah, well, I heard earlier that Brent defined high performance computing as turning a compute bound problem into an IO bound problem.
Exactly.
I have a slightly different definition, and that is that you never ever, for a high performance computing, the size of the machine, if you have a machine of size n, then you always need a machine of size n plus 1. And you have more cores, you're going to use more cores. You do finer meshes, you run bigger problems. You never ever have enough compute. So you learn to live within your means.
Right. So Roger, I think I skipped over you when I wanted to know a little bit about some of the system design requirements that the new chip either requires or can benefit most effectively from.
Yeah, I think actually the previous comments lead into a couple of interesting thoughts that do come back to the front end and base design as well. One is, that memory allocation. We're used to having surplus memory around. We just haven't had to manage that in a while. To Stu's point, it's cyclical, and we keep coming back to different points where it's critical to pay attention to it. But what we get now is the bandwidth that we were chasing that led to the excess memory in the first place. So that rebalancing is a tremendous opportunity. Because of the state that you're hearing, we're seeing in-house codes where the IP is embedded. That's where people are putting their work and seeing where they can get kind of the best bang out of it. And the nice thing is, we're not this architecture does not ask you to refactor for a novel implementation or an accelerator or something else. You can now, and you heard it a lot, you can now very quickly be productive and be working on how to take advantage of it, match the best parts of your application that are suited for it to get the best payoff. And so the return on investment is and the time to value is really high if you can find those spots that match really well. And that's what we're seeing. The other thing we're seeing is conversations like this, where we've got open source codes, we've got public projects, things we can talk about, because this is benefiting people where their value is the highest on their software engineering investments. Those tend to be the ones they don't want to talk about outside. They're developing competitive advantage. But do you want to spend 2 years, refactoring, or do you want to spend 2 months figuring out, hey, where can I really pick up the benefits of this architecture? And the things we're seeing, whether it's ARM SVE, and we heard a lot about that today, and vectors they're important again, right? And they're really relevant. Or whether it's HBM, or whether it's some of the software tools and infrastructure that we're hearing about, they're not unique to this architecture, this chip rather. So there's a forward path. So now you're on a path quickly, and you're looking for that benefit. And I think we're all, with anything really new, it's really exciting to see what users discover that it does really well that nobody saw coming. And that's part of the fun.
Great, cool. One of the things that popped up during one of the chats is I forget the exact chain of conversation, but someone wrote something along the lines of, "Oh, I did that on the VP 2000, the VP 300." Which dates some of us. You have to go back a number of years to remember Fujitsu's BP series lines when they were in the hundreds. Which brings up an interesting point. First, the long history of emphasis of vectors. Rod, you just said vectors are cool again, which is great. If we look at how we see the HPC world, there is now this Venn diagram of CPU users and CPU GPU users, in some sense, and the Fugaku system, is well regarded, and people do point out it's a non-GPU centric architecture. Can any of the folks that did any of the benchmarking here lay some groundwork or some sense of if this particular effort was done not on the Fujitsu part, but was done in a GPU world, some sense of how what differences would that have been? What does using vectors bring to the fore here that is not as easily attainable in a counterpart GPU-like environment? I don't know if anybody can address that issue.
I mean, I was the person who raised the VPP 300.
Oh, okay.
That was a vector machine I used to use in the mid-90s. So we ported DeVito, and we worked with Gerard's team to port DeVito to run on top of V100s, A100s, etc. And the code is faster, but in line with memory bandwidth. You know, the A100s have 2 terabytes, or the 80 gigs that we have 2 terabytes a second of memory bandwidth versus 1 terabyte a second of memory bandwidth. So something like DeVito, which is, you know, full waveform inversion, is twice as fast on an A100. So, you know, it literally took me 30 minutes to recompile DeVito for the ARM system. It took the DeVito team quite a long time to develop the code to run well on the A100s or V100s. So a lot of software effort. I think it really points to how well this system is put together, that you can take your code that you love and know. Sure, it might be x86, but recompile it with tools you know, and it runs pretty much straight out of the box, and it runs in proportion to how many flops in your memory bandwidth that you expect. That's our experience.
Great.
Hey, Stu, what do you think the relative effort comparing what you and I had to do 4 years ago to get KNL to work effectively with what you've seen with the A64FX?
I mean, it comes back, for us, it came back to, we've done a lot of work, as probably you have as well, on using the absolute lowest level programming language to extract the absolute maximum performance. But we have a lot of codes which use OpenMP directives to get vectorization, or let the compiler vectorize the code by writing your do loops or your for loops correctly. And the GCC and the LLVM handle those just fine. So those codes, it's been, you know, porting to the KNL was, you know, a 10-minute job for those codes, and porting to A64FX was a 10-minute job for those codes. The codes where we've spent, you know, 5 years working hard on the vectorization, the cache reuse, the memory bandwidth. I suspect we're basically should be able to just cut straight over to the A64FX. The SVE is not too different to the AVX512. So a little bit of work, I think, same vector length, a little bit of work on cache reuse, and a little bit of work on prefetch, and you should be there pretty quick, whereas it took 5 years on a KNL. It's quite a long process to extract absolute performance. So.
Great. Thanks. One of the questions that we want to get to, this is for Tukiyaki. Someone was asking a little bit about the compiler options that you use for your stream benchmark, and if you could just quickly, you know, run through the options that were there. If you have those at hand, that'd be great.
So the key point of the compiler option for the stream will be the Z field. You can see my text. So this interaction is a special interaction to the feeding the array in zero. So such a special interaction for the HPC contributes the stream benchmark performance. Mariam-san, could you have any other additional comment?
Otherwise, it's very simple. Usually, if you want to write the data to a memory, you have to read the memory into the cache and overwrite your write data and read back to the memory. That's a usual behavior. But using that field option, hardware knows that you will have to override all the cache line. So the hardware does not have to read the memory, the data from the memory, to the cache because you will override the whole contents anyway. That's the beauty of this, the trivial option, so that you can squeeze the hardware memory throughput.
All right, great. Thank you. I'm getting a signal here that we've actually run over our time, which is good. A lot of good questions and answers here. I want to thank everyone for participating in this particular session, answering questions. We got some great questions and comments from the audience, and we're going to basically throw it over to Keith Gray to give us our concluding remarks, and then we'll be able to call it a day. Keith?
Thanks very much, Bob. I do want to thank you and Earl for organizing this session. Speakers were great. This was a very, very interesting day. Thanks to all of the participants that made this practical. Let's ask that they remember to fill out the survey as soon as they can. And if they have other questions that we did not address in this session, Earl and Bob will still be available to try to correlate those and get those out to people. Thanks very much. Appreciate the opportunity to participate.
Thank you.